efficiently problems can be solved on a model of computation using an algorithm. Okay, so there came certain terms like model of computation. What is this model of computation? So this model describes how an output of a mathematical function is computed when the input is given. Model of computation describes how an output of a mathematical function is computed when the input is given. So keeping the things in mind that how the conversion process from input to output is performed, keeping in mind this thing, the machine for any problem is created. Okay, so say that whenever we want to create any machine, we try to find out how the output is found, or how the output is produced from the input. So this is the same thing model of computation describes, that how the output is found or produced from the for with any mathematical function when the input is given. Okay, so the very basic question here is, what is computation? When you talk about computation, as it is given in here, it is any type of calculation that can be arithmetic or non-arithmetic, following the steps of a well-defined model. Example of model given is algorithm. Okay, so what is this arithmetic and non-arithmetic steps that is mentioned here? As we discussed in the previous class, that arithmetic operations we already know, addition, subtraction and all those things. But computers that are built nowadays, that not only are confined in performing arithmetic operation, they do other tasks also. Okay, so we have come far along from the arithmetic operative computers. Now they also perform non-arithmetic steps, non-arithmetic operations. So computation not only include arithmetic operation but also non-arithmetic operations. So when we have given example, we have given example of human brain. So all of these things together, theory of computation is the branch of computer science and mathematics combined that deals with how efficiently problems can be solved on a model of computation using an algorithm. Also, our main concern in this course is that finding out the capabilities, what a computer is able to do, and the limitations of a computer. The capabilities and limitations of a computer is going to be found out through this course. Okay, so there are certain areas or three areas to discuss in theory of computation. They are known as automata theory, computability theory and complexity theory. The things we have discussed in previous class. We discussed about automata theory. Obviously, there was a brief discussion because in the introductory chapter we only give you a vague idea about all the things. Okay, so automata is deals with the definitions and properties of mathematical models of computation. Automata theory deals with the definitions and properties of mathematical models of computation. When we talked about automata theory, we have talked about certain things. There are many models that are used in this computer science. In different areas of computer science, there are different models that are used. So, two to mention: finite automata and context-free grammar. So we have said that finite automata is something that is used for text processing, compiler design, and hardware design. Whereas context-free grammar is used for programming languages and artificial intelligence. So when we talk about compiler design, compilers are designed using some concept of finite automata. Not exact rendition you will find, you will see that it takes inspiration from finite automata. So I told you in the first class also that don't try to match the match the whole thing. They have if you are doing the two courses together in the same semester, so context free they take inspiration from finite automata, or say they take the essence of finite automata, but those two things are not totally same. Okay, so don't mix these up. Okay. Uh, Automata theory also allows practice of formal definition, as we already said. Now we have two more theories: computability theory and complexity theory. Last day we have talked about computability theory, which tries to find out which problems are solvable by the computer and which are not. So computer cannot solve all the problems, not all the mathematical problems, and it can solve. So for example, we have said that is written in the book, in a book I have found that any no computer, I have not verified it, that's why I am mentioning about the book. I have not verified, that's why I have mentioning about the book. The thing is, uh, the problem we have also the example we have also talked about in the previous class, that is that mathematical problems, there is a mathematical problem that says find out if this expression is true or not, true or false. Find out if this statement is true or false. This can be done if, as we do mathematics, we can do this, but there is no computer that can do that or solve that problem. Finding out if any expression is true or false. It is said by the book. It is not said by me. Okay. So if that problem is not solvable by computer, what are the reasons that the computer cannot solve those problems? This is what we do in the computability theory part. We try to find out the problems, classify the problems if they are solvable or not. Next, we started to talk about complexity theory. So the question complexity theory answers is what makes a problem hard or easy. There are problems we say that this is an easy problem and this is a hard problem. Okay, so whenever I do maths of and I try to make you learn some mathematical problem, or I will try to make you learn the problems related to theory of computation, I will say that no, that is easy, or you will for you have seen these things, or you are experienced with these things, that certain mathematical problems you don't understand and you go to your teacher for consultation and they say, oh, you don't understand this. I also say that same thing. They say that you don't understand this is very easy. Or in the exam hall you say that ma'am, question was very tough, and your teacher will say that, I will say that no, it was very easy, I taught you in the class. This type of thing. Okay, so what makes it easy to me and what makes it easy to other person? If I think about it person wise, then it varies on the level of their knowledge. Okay, but now our concern is what makes it easy for a computer and what makes it easy or for a single person, for me, not person to person. I'm not varying it person to person. I'm saying that for a single person, say before going to computer, why is it easy to me and why is it hard to me? What makes it tough and what makes it easy? Okay, so for example, we have said I can add 100 with 200, but I cannot add 2, 3, 4, 5, 6 with 7, 8, 7, 8, 3, or 6, 7, 5. All of them together. It will take me time, but I can do that, and the chances of being it correct is very low. But it can be done, but it is tough one. So the problem with this thing is that how it is tough and how is this easy. How one problem is tough and how another problem is easy. It is the question that is answered by the complexity theory. So we need to deal with many tough problems. That is the problem here, that we need to deal with many tough problems. So what do we do for these tough problems? Okay, how do we classify these problems? classify these problems into hard one or tough one. Okay, so there are many options you can do when you are when you okay, easy problems, there is no problem with the ones that are easy, but when we apply the complexity theory, we actually answer the question that what makes this problem hard. You have a problem, and when you apply the complexity theory that you are going to learn, then you will find out why this problem is hard and why this problem is easy. So how do you do this? How do I find this out? Okay, what are the options or what are the schemes I should apply when I see a tough problem? Okay, so first thing you can do, that you can try to understand which aspect of the problem is root at its difficulty. You can try to find out which aspect of the problem is making it is at the root of this difficulty. Then you can alter that problem, or you can alter that root or solve that one to make the problem easily solvable. So the hard thing, I guess this is the hardest part, that finding out the root of the problem and then solve it. If you Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
First thing, if you encounter any computationally hard problem, the first thing you can do, you can try to find out what is at the root of this difficulty, and you can alter that, or you can solve that if you find out the problem. So finding out the problem of this, that is behind the finding out the root behind this difficulty, is the first thing that you can do. And as it is mentioned first, I think this is the most difficult part. If we know what is the problem, then we will be able to solve it, but finding it is very difficult one, and that is why it is computationally hard. Okay, so if your problem is hard and you fail to find out at the what is at the root, now what you can do? Secondly, you can do that, you are not going for the perfect solution, you are going for a solution that is less than perfect. So you are going to find out approximate solution. So when you are encountered with some computationally hard problem, at first the best solution is you can find out the root of difficulty. If you cannot do that, next you can go for a solution close to perfect or approximate to the perfect solution. Okay, you can do that. Now, so that is another thing you can do for the solution of these problems. Now there is one more thing, thirdly, that is you can do, that there are many problems that when they are behave in base situation they behave well, and there may be in average situations also they are okay, but they are hard only when they are in the worst situation. Like you can talk about different algorithms like binary search or different type of search algorithms that you apply. So if what is the best case of the search algorithm? You find it in the very first place. That is the best case. And you find it in the middle of the, while you are searching, you find it in the middle. So that is average case. And in the worst case, if there is 1000 data, then it is going to be hard to do the searching task, isn't it? So in that case, these are the problems that are hard only when they are in the worst case. So you have to be do optimization, that do you want to do it faster, or do you want to go for a slow solution, but that will run quickly, or you can you have to make decision in these cases depending on the application. You may be satisfied with a procedure that occasionally is slow but usually runs quickly. Okay, that means that when the problem is small, or problem is in this base situation, it may be slow. So maybe it is taking time in the, it is there are some things that it takes time for small amount of cases. Like when there is a small amount of data, it takes time, but when there is a huge amount of data, comparatively it seems that it is running quickly. Okay, so you may go for that type of solution in like that. Okay, so there are these type of things that are concerned when you are talking about complexity theory. So complexity theory, if we want to say real life application, how it directly harms the real life application, one real life application that is directly affected by this complexity theory is cryptography. What is this cryptography and how it is affected? Okay, so what do we do in cryptography? What is cryptography? Do you know anything about this?
Ma'am, I think it is something like a secret message.
Okay, uh, don't you have any course related to this? Did you not have any course related to this? Are you sleeping?
No, ma'am, we don't.
No, ma'am.
No, ma'am.
Do you have any course like microprocessor or something like that?
Yes, ma'am.
Yes, ma'am. Microprocessor and assembly course, ma'am.
Wasn't there cryptography?
No, ma'am.
No, ma'am.
Okay, I don't remember, but we also had cryptography in some part, maybe in algorithm or something. So cryptography is used to encode some message. Some secret messages are encoded. You cannot just send the message for like secret missions or something like that. They use cryptography for sending this message through mails. Like secret messages sent. Okay. Now, how it is affected by complexity theory? So, say if you encode the message in a very easy way, is it in a very easy way? That is, if you see the if anyone sees the message, he will be able to decode the message. You have encoded your secret message in a way that anyone who is seeing the message will be able to decode it. So this is not the purpose of cryptography. The purpose of cryptography is hiding it from all others except for the person for whom it is meant to be. Right? So we want the cryptography to be hard so that no one understands this. The purpose of cryptography is to make the secret code harder so that no one understands it except for the person for whom it is made. So it is a complex situation. Here the hard thing is what we want. So for this problem, we have to. This problem has led to the is inspiring the cryptographers to work because we want many advanced cryptographic technique that will be hard enough to make, but that hard enough to make, and it will also take less amount of time. And the solution of making this of doing this hard task will be easy. So we have to do this hard task of cryptography with some easy manner. That is the complex part of complexity theory. So all these things are just intertwined. That's why it sounds very like golmele, isn't it? So this is the problem with complexity theory. That's why I have not talked about it yesterday.
Ma'am, cryptography is more like than encryption, ma'am.
Encryption is cryptography.
Okay.
Okay, discrete match, you said. So I remember right now that it is discrete match. So encrypting any data is a part of cryptography. Okay, so we want to encrypt it harder so that no one understands this, but we want to do it in an easy way. So that is the complex situation. We want to achieve the hard part with some easy manner. Okay, so we will see things, applications of these things in future, but we have to go through some basic parts for learning theory of computation. Why is it? Because as we said that theory of computation is a combination of mathematics and computer science. So, and we have done the mathematical courses in the very first years of our uh, very first or second years, second semesters of our math honors life. So we are going to go through the basic mathematics that will be needed in here. Okay. So there is one more thing that about models of computation. About models of computation, I need to tell you something about that, but not today. I will talk about that in some later classes. Okay. So we are going to talk about something that we know and we will find it interesting because we have a 2 hour class. That's why we need something interesting to discuss about. So today we will discuss about the mathematical portion of this. So the mathematical topics we are going to discuss, mathematical notions or say terminology that we are going to discuss about today that will be related to the course, and we are going to start from set. As you can see and as you already know, set is a group of objects represented as a unit. So inside the set, normally while doing mathematics, we try to inside the set we try to mention about only the numbers and all that. But there can be other sets also that we apply in the computer science. That's why the set is mentioned here. That you may use. We have used set for mathematics for the purpose of mathematics in our earlier life, but now these sets we are going to use to mention about many other things, many a set of students, a set of tasks, or set of many other things we are going to use. So set is a group of objects represented as a unit. Okay. Now this group of objects or the objects in the set are called elements or members of the set. Elements or members of the set. Now, these elements or members we represent using this sign. As you can see, that the the membership we represent using this sign. Maybe this sign is not proper, but you know how to do it, right? This epsilon type sign represents membership, and epsilon with a cross mark or say there is a backslash, it will be above the epsilon mark, is known as membership. And how do we mention this membership? We say is like this: set A or any item is a part of the other is part of a set or not. We mention it in that way. How do we mention it? If certain things, if certain things or certain elements are part of any set or not, we mention it in that way. Okay. So if I say there is a number 8 or say 8, so is it a member of this set?
No, ma'am.
No, ma'am. No,
No,
ma'am.
ma'am. For that we are going to use this symbol. Okay, let me copy this thing. Board is a must for theory of computation. That cross is not copied. Why is it moving? It's not a part of S. So it's not a member of S. So if I say 7, 7 is a member of this set. So these are the symbols used for showing membership and non-membership. Now another thing that comes up is a subset. So what is a subset? It is represented as using this symbol. We can see it means that A is a subset of B. And how A is a subset of B and what is the definition of a subset? it says that if we write A is a subset of B in this format, it means that all the members of A are a member of B. Every member of A is also a member of
B.
B. Okay, now tell me what is the subset, what can be a subset of S? Any subset given 50, 21, 57 can be a subset of S. And
Every individual elements also will be mem subset.
7 individually will be a subset, 21 will be also a subset, and as it says, it can be equal. That means 7, 21, 57 also together will be a subset of S. Okay, that means if I write that A is equal to the same thing, I don't need to write this. So if I say, so it will be also a subset of S. This entire thing will also be a subset of S. Now, as it goes with the sign, this the sign above is a sign of subset, and the sign below refers to equal sign. Okay. Now it says that A is a subset of B. So that means every member of E is also a member of B. So what is this proper subset? What is this proper subset? Can anyone tell me? Do we remember? Are you sleeping or giving search?
No, ma'am.
What is a proper subset?
Memory to all the elements of the set.
Do you remember or not? Tell me that.
Or maybe not.
Not remember, ma'am.
Okay, forget, ma'am.
It says that every member of A is also a member of B. So in the definition of subset, so proper subset is one that in which every member of A will be a member of B, but they are not going to be equal. A and B will not be equal in the definition of proper subset says that. That means there will not be the sign that is equal. It is there will not be the equal sign below. It will be only A is a subset of B, and when all the members of A will be in B, but they won't be equal. That means any subset like A is mentioned here will not be a proper subset. Will not be a proper subset because it contains all the members that is in B, and they cannot be equal to be a proper subset. So this is what is proper subset, where every member of A is also a member of B, but they are not equal. The member are not equal. Okay. Give me a second. I have a call to receive. Okay. Now, as you can see, there is another set of elements mentioned here where there are 3 sevens. You can see there are 3 sevens. Okay, you can see this. So what should be happening through these 3 sevens? If it is a set, what should be happening to these 3 sevens?
Ma'am, it's just a one.
We have never used a same item
Ma'am,
group.
the member will repeat or the 3-7 will repeat in same time.
So it is repeating itself as we can see, but we have never actually used the same item multiple times in a single set, isn't it? So if we want to take the number of occurrences of the members into account, what it says in the next line, you can see that if we want to take the number of occurrences of members into account, we call the group a multi-set instead of a set. Thus, these are different as multi-sets but identical as sets. So when they are separate in different sets, then then they can be taken into account that these sevens can be considered different. But when they are in a single set, we don't consider them the same. They are like one, but we have to consider them that they are a part of other sets. These sevens, 2 sevens are part of one set and 1 7 is a part of another set. So it is an anomaly. Why? Because we don't know which 7 are we talking about. Are these 7s we are talking about, or the first 2 sevens, or the first and third 7, or the 7 in the second place? So that is still anomaly. That's why we have not considered the identical items in a set. If we want to consider their occurrence, then we have to consider them as different sets or multi-set instead of a single set. Okay, so there are many other sets and all of their names are mentioned here. And before going to those parts, okay, what is a set of natural numbers? A set of natural numbers. Now tell me, what is natural number?
Ma'am, 1, 2, 3, 4.
1 to
Three.
10, right? Okay. So what is a set of integer numbers?
Ma'am, only integer value can take in this set.
Now what are the values that are considered as integer?
Ma'am, 0
Ma'am,
to 9.
Ma'am, minus and plus.
-1 to +1.
Ma'am, all the real numbers are integer numbers.
Okay. So in integer part, take a cue from the programming. It takes the minus number and plus number, but the complete numbers or purno সংখ্যা we can say. Minus purno সংখ্যা and plus purno সংখ্যা. So negative part and positive part also. And how it does empty set look like? So empty set means there will be nothing. Empty set looks like,
Null set.
also known as null set. It will be like this, or there is a symbol like phi maybe.
Only a bracket.
Only bracket is empty set. There is a symbol like phi, which we also can take as empty set. Okay, so singleton set is the one in which there is only a single element. Singleton set is the one where there is only one element. Unordered pair. When there is two elements in a set, that is, sorry, known as unordered pair, like this one can be considered as unordered pair. Okay, so there is, before going to this part, union intersection that you already know, let us talk about power set. What is this power set is? We are reminding ourselves the elements that we will be needing for theory of computation and reminding ourselves with the basic mathematical items. So tell me, what is a power set? Do we remember what is power set, or I will tell you? Just tell me that we don't remember, then I will go with that.
Ma'am, the subset of taking each and every element
It is actually
differently.
not each and every. You can each and every should be used earlier. The definition you are giving, the terms are uh, right in their in the sentence, but they are not in the right place. The thing is, each and
Ma'am,
every subset of any set. Each and every subset of any set. So
Yes,
if this is a set, what will be the power set of this set?
ma'am, 4. That means 3, 8, 3, 8, and one empty set.
Empty.
Total 4.
So there will be four items that you said, and how do we find power set? Say this one, and 8.
3, 8, and
There is
3, 8 together.
comma, and then 3 comma 8, and then there will be one empty set, and done. So there are four elements in the power set for this set, and you, as you said, there is four. And how did you find out? We all know that it will be 2 to the power the number of elements. It will be 2 to the power the number of elements. So in this case, the number of elements is 2. So the member of power set will be 2 to the power 2 or 4 elements, right? So the definition of power set says that power set is the set of all subsets of any set. Power set is the set of all subsets of any another set. So what are the number of elements in a power set? It is 2 to the power the number of elements in the set. 2 to the power the number of elements in the set. So see this thing carefully. The elements inside the sub power set, we have kept them inside second bracket. So see this thing carefully, because while we talk about Cartesian product, these things are going to change. So what is Cartesian product? It is the multiplication or arrangement or combination of the sets. You can say, so say I have one set 2 3, and Cartesian product is represented using the cross sign, not this star sign. It is represented using the cross sign. So if I perform a Cartesian operation in this and find out the Cartesian product of these two sets, what will be the output? What will be the output for this one?
2 comma 1, 2
I'm 2,
comma
1, 2,
6,
6, 2, 4,
2
3,
comma
1,
4, 3 1,
3,
3
6,
6,
3,
and 3
4.
4.
2 1. And inside which type of bracket?
Ma'am, second bracket.
So that is why I said that, see
Ma'am,
the
first
First
bracket.
bracket.
Ma'am, first bracket.
first bracket, and total thing will be inside.
Second bracket.
Okay. So that is why I asked you to see that power set includes second bracket in all places. So you can write it 2 1 2 6 and 2 4. There will be 3 1 3 6 and 3 4. So if you have any confusion related to these things, you should ask, because I don't know how far I will be able to go. But if I cannot be able to go to the exact mathematical items, then this will be the mathematical items coming in your exam. Okay, so this is one thing. So what is union? We know union. We have some idea about union. So
Yes, ma'am.
union is an operation that union, intersection and complement are some operation that we perform on the sets, on two or more sets, right? Union, intersection and complement are the operation we perform on two or more sets. So union operation actually is it's like OR operation or logical operation, right? It takes every item of two sets. It takes every item of two sets.
Yes,
As
ma'am.
you can see, if 2 and 3 are two sets, so what will be the union of them? What will be, if we perform union operation, what will be the result?
Ma'am, can you please tell me the set again?
2, 3 and 164 that is mentioned here.
Oh, ma'am, that will be 1, 2, 3, 4,
One, two,
6.
three, four, six, ma'am.
That means all the elements will be there. So union is the operation that takes all the elements. And intersection is the element operation that only takes into account the common elements between two sets. So what will be the intersection of 2, 3 and 164?
Ma'am, two and three.
Ma'am,
No element.
No,
null
no
set,
element.
no element, null set.
So for union operation, our symbol is U. This type of one thing. This is not actually U, but it looks like U. And intersection operation. So please remember the sign. I cannot do it right now. I cannot draw the sign right now. I don't find it here. It is just ulta U for intersection. U in reverse. It will be like N, something like N, right? So this is for union sign and this is intersection sign, and complement is operation of subtraction, minusing one set with another set, but not like the traditional mathematical minus. It doesn't perform the minus like traditional mathematical minus. It has a different way of doing this minus. Okay, so if I perform complement operation between these two sets, 2, 3 minus 164. Why I mentioned about the traditional minus? Because in that one, they require the first one to be the bigger one and the second one to be the smaller one normally, but we can also accept minus values now. But what will be happening if we perform complement or subtraction of sets? So 2.2 comma 3 minus 164, what will be the result?
Two and three, madam.
So why it is 2 and 3?
Ma'am, we know that, ma'am, if the first set have some elements and then second element, if they are similar, then the second key elements are not counted.
Okay,
And here there is no similarity. That's why the first set will be counted as a result.
okay. Now tell me what will be the result if I do complement 2 3 minus 3 8.
What, ma'am?
2 is set 2 3 minus 3 8.
Ma'am, only 2.
On so
Only two.
what is happening here is the first one which we are using to subtract the second item from. So if there is any common item, that will be eliminated and the not common item will be there only. The common item will be eliminated and the not common item from the first set will be there as a result of complement. So as 2 and 2, 3 and 3, 8 has 3 common, so the output will be 2 and they don't have anything common, 2, 3 and 164. That's why 2, 3 is still there. Okay. There is one more thing left, that is Venn diagram, which we know is a diagrammatical representation of sets. When two sets are connected together, if I want to show you a picture, so give me some time so that I can bring a picture of this. If there was a board, I would have drawn this, but now we don't have anything. this is one Venn diagram. Can you see this?
Yes, ma'am.
Yes, ma'am.
We use circles to represent a set. Okay. So from the picture, I can tell you the question that it is a Venn diagram of the sets. This is a Venn diagram of the sets where one set, the first one is the first circle is the set of elements which starts from T and ends at Z. First circle is the set of the elements which starts with T and ends at Z. Third circle is the set of elements which starts with Z, which no, it is not the element which ends at Z. Z. It is only the elements that starts with T. The words that is starting with T. Last one is the words that is starting with J, and the one in the middle, it is all the elements, all the words that ends with Z. First one shows the is the set of elements that starts with T, and last one starts with J. The one in the middle that shows the elements that ends at Z. Okay, now all of the T, there is an element you can see topaz that is written that starts with T and ends at Z. So it holds an element of the middle one. That's why they are intersected here. This intersection part shows the elements that are starting with T and ending with Z. Now this one is also same. It starts with J and ends with Z. Okay. So this is how Venn diagram is drawn for different sets. So let me give you a set and draw me the Venn diagram, or I will see you. I will see the answers. And you have to mention each part inside the diagram. Now draw a Venn diagram for these sets. Okay. Draw a Venn diagram for these sets and mention the portion. These sets that is mentioned here. Can you see the sets?
Yes, ma'am.
Okay, so you will draw a Venn diagram, and like this one, you will have to mention what are the elements that is in the intersection part and what are the elements outside the intersection part. Okay, let me change this thing again. Okay, it has become very much sensitive. So you have to find out a Venn diagram for these sets. You have to mention each part where it is there, what is the in the outside part, and which set it is, and how you are going to show me the you are going to write the answer in your khata, and you have to take the picture of what you have done in your khata. Then you will share your screen and show me the picture. Are we clear?
Yes, ma'am.
Okay, now do this.
Ma'am, done.
Who has completed?
Yes, ma'am, done.
Ma'am, done.
Okay, who said first? The one. Have you taken
Me?
picture at all?
Yes, ma'am.
Please, please tell me your name. Can you hear me?
I'm Shabiul Alam.
Okay,
Yes, ma'am, I can hear, ma'am. This is Shabiul Alam.
okay. Please share your screen now.
Ma'am, can you see?
Yes, I can see. Can you see? Let's see is there any problem. If there is any problem or not, let's verify this. Okay, what about everyone? Is it correct?
Yes, ma'am.
So does it match with yours?
Yes, ma'am.
Yes, ma'am.
It was a bit complicated than the one that is been showed in the picture, right?
Yes, ma'am.
Okay, but you have done well. Thank you, Shabiul. You may stop sharing. Okay, I hope that all of you have completed the one that was given. Now we are going to go for another definition in this part that maybe is not written here.
Ma'am,
Yes,
can you please give us for 10-minute breaks for us or pairs?
I also want a break, but I will finish first. I will not take the 2 hours. Or you want a break?
Okay, ma'am.
I'll finish first.
Which one you want?
I'm finished first.
I will
Ma'am, finished first.
I will take 20 more minutes, then I will just stop. Okay.
Okay, ma'am.
Are you recording our classes?
No, I am not recording. You are supposed to record. You have not asked me. Okay, slides will be given. It
Okay, ma'am.
won't be a problem, I think. And book will also be there.
Okay, ma'am.
Before going to the function part, there is one more thing that I have not said. That is known as sequence. And what is this sequence? It is a part of the set. Sequence is something that is related to the sets. That's why I have not moved to function. Sequence of objects is a list of the objects in the set. Sequence is the list of objects that are in the set, but they are in some order. They will follow some order. So you can represent or you can put the elements of a set in some sequence or in some order in the sequence. The main part here is the elements of the set should be following some sequence, or it is known as sequence, should be following some order. And what is this thing is, let me tell you or show you the example. So so this is A is a set. So how can we make a sequence out of A? We can say that 1, 2, 5 and 6. It is a sequence for the set A. Okay, but sequences follow order. The thing that I have written here, it is following an order that I have put. And what is this order is, so if you write 2, 1, 5 and 6, which is also all the elements of this set, isn't it? 2, 1, 5, 6 also contains all the elements of the set, but the elements are not in the same order as this one. So these two sequences are different. These are the two same these two sequences are for one set, but these two are different. Okay, because they follow the different order. They are element of same set, but they are two different sequences. Different sequences of same set. Now, the repetition of item doesn't matter in the set, but repetition of item matters in a sequence. Those things that didn't matter in a set now matters in the sequence because there is some order. Now, if in any sequence there is two elements, say this one, or I can say this one, if in any sequence there are two elements, it is known as ordered pair. Why am I saying ordered pair here? Because in a previous one I have talked about unordered paired. You may have not, you have forgotten that unordered paired, what is this? So in a set, they don't follow any order. Two elements are there, but they are not following any order. So one element is there, that is singleton set, and when there is two elements there in a set, that is unordered pair. But when in a sequence there are two elements, then it is known as ordered pair. And why is that? Because they are following some order. Okay, this is not same as 8-2. It is always 2-8. It is 2-8. Okay, that is ordered pair. Now our next part is functions and relations. So it is going to be like a bit critical because the elements that has been mentioned here a bit critical than the other one. Okay, what is function? Function is an object that sets up an input-output relationship. So that is mentioned here. Function is an object that sets up an input-output relationship. We can also say that function does the task of mapping. Function does the task of mapping. Function is an object that sets up an input-output relationship. So this function is setting up an input-output relationship between A and B. This relationship we can also call as mapping, which is we can say that if A is function of A is equal to B, we say that if F maps A to B, function is setting up a relation input output relationship between it's an object that is setting up relationship input output relationship, and mapping is we can call the relationship that function of A is mapping A to B. Now the inputs in a function, all possible inputs in a function are known as domain, and the all possible outputs of a function are known as range. The all possible inputs in a function are known as domain, and all possible outputs of a function are known as range. So when the domain contains k arguments or k elements, when the domain contains k arguments or k elements, then it is known as k-array function. So we are familiar with binary, unary, isn't it? This is k-array function. So k is called arity. With the term array, the arity came up. So that means if there is k inputs, k amount of inputs for any in the domain of a function, then the function is known as k-array function, and k is known as arity. So if in the domain there is only one argument or one input, one argument or one input, then it will it will be known as unary function. Okay, if there is two elements, then it will be binary function. So we have two names for these two, that's why we can use unary or binary, but there can be more. Okay, 3 array function there can be, 4 array function can be. So k is also known as arity. So it refers to the things that refers to the arguments that are in the domain of a function or for the input of this function. When we have a binary function, so let me give you an example of unary function. So say there is a function that is known as absolute. There is a function that is absolute function. We have used this absolute term very much in our intermediate studies. Absolute, or in Bangla param man, right? So the absolute value of any element is the function of absolute value. Say this star is not the thing that I want. Absolute value of, sorry, again, absolute value of a is equal to b. So what is this? The value of a. Say, so the value of a is all natural numbers, or say all integers, all real numbers, we can also say. So the absolute value of a is all real numbers. Okay. So are how the output is going to be? That's why the thing is, it is absolute value, the input in the domain, I said all real numbers, isn't it? In the input domain, what I said is there is all real numbers. Now what are these all real numbers? This can be minus values, this can be plus values, and this can be 0. But what will be the absolute value output? The output will be if z is equal to -1. By z I mean it is representing all the real numbers. Okay. By z I mean to say it is representing all the real numbers. Now, so if I write absolute value of -1, what will be the output? It will be 1.
One.
Okay, so we can say that it is all the absolute value of all real numbers. We can say that it is also a real number, or we can say it can be a natural number, right? But it is okay to say z, that is all real numbers. So the argument involved in the domain is 1, isn't it? There are many numbers that is inside z, minus infinity, -1 to infinity minus, or plus 0 to, so minus infinity to plus infinity, all numbers are there. But with one argument we are mentioning that, isn't it? Why? What is the reason that I am giving this example? I said that if there are 2 inputs or 3 inputs or k inputs, the term is not input actually, the term is argument. And what do I mean by argument? There can be only one thing that is representing many things. This is the argument that I wanted to mean. That means that by one thing I can mean everything, but there is only one argument. That's why it is unary function. How is that? So it will be in the domain there will be only z, and in the range there will be also z. But our concern is in the domain we have z only. Okay. In the domain we have only z. The only argument we have is z, that is representing all real numbers. Now a binary function. A binary function, so that is not related to this. Say add. Add is a binary function that is being performed on 2 elements. Add obviously will be performed on 2 elements, say a plus b, and it will be equal to c. Okay, so there are 2 elements, or I don't I'm or if I am saying you to add 2 elements, so how many arguments will be there? How many arguments will be there? If I ask you to add 2 elements, what will be the output? How many arguments will be there? So as there is two elements, and I am saying that you
Two
have to
arguments, ma'am.
two arguments will be there. You cannot just write z. Say real numbers you are considering. You cannot just write z. There will be, so in the sense of arguments, that is represented like this, using a cross sign, not the star sign. It is used the cross sign that we normally use, not the star sign. Okay, don't use the star sign for function. The places I have said that there will be a cross sign. Okay, the multiplication sign we have used from our childhood, that is going to be used here, not the star sign. So this is how the domain will be represented. The domain of this function is z cross z. That means there will be two arguments. It's a two array function. Okay, it's a two array function. So I now the last line, let me explain this thing to you. When there is, it is not going to be like this, it is going to be this. Okay, when there is, it is saying add a and b, add set a and set b. Okay, now when there is two array function or binary function, when there is a binary function, you actually use infix notation like this. Normally we like to use infix notation like this. So how do we represent this? A plus b. If you only write a plus b, it will be fine, instead of writing like this. Okay, infix notation means the notation will be placed in the middle of the function, and prefix notation is the one that we are using here. The function name is mentioned in the first place. Okay, so if it is a binary function, we normally use infix notation like this. It, the meaning of this thing is the same as add a comma b. Okay, so this is one characteristic of this function. So let me go through the things that we have learned today. First thing, we have gone through complexity theory. Complexity theory answers the question that what makes a problem easy and what makes a problem tough. And we can, if we encounter any computationally hard problem, what should we do? We can either find out the root behind the difficulty and solve that, or we can go for an approximate solution rather than going for the exact solution, or we can find out if the problem behaves only like this in the worst case situation or not, and we can just take decision accordingly. We have given example that cryptography is a direct target or direct impact or effect of complexity theory. And after that we have started to learn some mathematical notations that will be needed while we study the theory of computation thing. And we are done with the set part. Now we are learning the function part. We have seen some portions of the function, and we have seen the application of Venn diagram with some parts of it. So there is not written the part sequence, so don't miss that. Okay, let me write this here. Sequence should also be there. And we have seen functions, where we have seen what is function, what is mapping, domain, what is domain, and what is range, and the arity of a function. Okay, these are the things we have seen today, not anymore. I guess my voice is going to be broken after this. Do you have any questions?
No, ma'am.
No, ma'am.
No, ma'am.
If it was if it is our regular classroom, I guess in the class hour like this, most of the people would have been sleeping. So I guess it is also happening there, also because you are in house and doing the class laying in the bed. So I guess It is also happening there. Just I cannot see.
No, ma'am.
Rokulul Hassan Shimul, I know you always attend the class. I can recognize your voice. Maybe you are not sleeping, but others can be sleeping.
Not ma'am, not sleeping.
No, ma'am. No,
No,
ma'am, not
no ma'am,
sleeping.
no ma'am.
No, ma'am, we are not sleeping, ma'am.
Ma'am, silent member, ma'am.
Okay. Don't
Yes,
get,
ma'am.
don't maintain the awkward silence. Silence.
Okay, ma'am.
Our university site is not working.
ম্যাম তাহলে কি আমরা এখানে চ্যাটে লিখে দিব?
Giving
Ma'am, I have a
warning.
question, ma'am.
Okay, so you should write your name and your ID in the chat section, please. For today, we should follow that.
Ma'am. Ma'am.
Yes?
Ma'am, whatever we have covered today in this
I
class.
cannot hear you.
Ma'am, can you listen to me right now?
Yes, Shabiul.
Yes, ma'am. So, ma'am, whatever we have covered today, so we have to go through these slides only, or we have to read other things?
No, slide, as I said, slide is not informative. I will provide you with the book. I just got the book. I am going to give you that.
Okay, ma'am. Thank you, ma'am.
Okay, thank you. Write your name and ID in the chat section.
Okay, ma'am.